Fluvial processes involved in river valley and river channel formation. And you know what? This is the part 4 of river environment. So that means there is the part 3, part 2, and also the part 1. So go check it out if you've not checked it out. Okay, part 1, I think we were talking about hydrological cycle. That was the first part, and second part drainage basins, third part river regimes and hydrograph. Now the fourth part is a fluvial process involved in river valley and river channel formation. Okay, so go check that out, and in case you've not subscribed, make sure you do so. All right, so let's start. I normally start with the learning objective, what you're supposed to achieve at the end of this lesson. All right, so what are you supposed to achieve? Now, by the end of this lesson, you should be able to know this. You should be able to know the fluvial processes involved in the formation of river channels and valleys. And also, you should be able to know how the characteristic of a river channels and valleys change along the course of a named river. Okay, so by the end of this lesson, you should be able to understand all this, because that's the whole thing, what is entailed in this lesson. Understood? Now let's start immediately. So what are these fluvial processes? We've talked about fluvial. What are these processes we're talking about? Okay. So when you talk about fluvial process, we refer to the various or natural activities and phenomena associated with rivers and streams. Okay, those natural activities that happen in rivers and also in streams, and they are natural actually. We call that fluvial processes. Okay, now these processes are responsible for shaping the landscape, okay, of that river. You see, we are going to look at several landscapes actually in the part 5. Make sure you subscribe so that you get notified, or maybe once I upload the video you just find it there. Okay, so these processes that we're going to talk about, the fluvial processes, they're the ones that are responsible for shaping that landscape of that river. Okay, when we talk about a v-shaped valley, the process behind that is a fluvial process. So we are going to discuss more of that. All right, so let's look at the key fluvial processes, the key fluvial processes that we are going to talk about. So the first one, we're going to talk about erosion. Okay, and in erosion is we talk about it's the wearing away of rock and soil by the action of water. Okay, so the soil is just weared away by the action of water. That's what we call erosion. Okay, so it can occur through both vertical. When you talk about vertical, it can be down cutting to the ground. Okay, just down cutting. Okay, increasing that depth, down cutting, the vertical, and also the lateral. When we talk about lateral, we mean sideways. Okay, that the banks, the side of that, the bank of that river. Okay, that's what we mean by lateral. Okay, so it can be both vertical, or sometimes you say down cutting, and lateral, sometimes you can say sideways erosion. Understood? That is the erosion, is one of the fluvial processes that takes part in a river. Okay, then we're going to talk also about transportation. Remember, after erosion, the rock has been weared away. It's going to be transported, like moved. Okay, so the movement of eroded materials such as sediment and rocks by the flowing water of the river. Okay, now we have a process of transportation. Actually, we're going to discuss one by one. We have traction, saltation, suspension, and solution. So we're going to talk about that just some coming time. Okay, it's just on this lesson we're going to discuss more on that. Right, then we have deposition. Remember, after it has been eroded, transportation has taken place, and now those materials that have been eroded, transported, they're going to be deposited somewhere. That's where deposition now comes into place. So the settling of transported material when the river's velocity increases, okay, decreases, not increases, but decreases. Okay, when that flow of the river kind of the speed reduces, we're going to have those materials that are transported by the river being deposited somewhere. Okay, so deposition leads to accumulation of sediments, contributing to formation of various landforms that we look at in part 5. Okay, so make sure you subscribe so that you get notified once I upload that video. And then we have also the supporting part, which is weathering and mass movement. Okay, I know you've heard of these, weathering and mass movement. So when we talk about weathering, we mean the breakdown of rocks in smaller particles, actually without movement. That's when you talk about weathering. The breakdown of rocks into small particles, but without movement. Understand that. But when you talk about now mass movement, is the movement now downslope due to gravity. Remember here, movement involved. Okay. First, weathering, the breakdown of rocks into smaller particles but without movement. But now the movement of materials downslope due to gravity is what we call mass movement. Okay. So weathering provides the loose material that river can transport. So all these things that you're seeing here are called fluvial processes that we discussed when talking about rivers. Understood? Now, let's look at each one of them now, break down each one of them, all the fluvial processes, okay? The first one we are going to talk about is erosion. And we talked about vertical erosion, which is down cutting. So it occurs when a river cuts downward into its bed. So that is means it deepens the river channel, okay? Is often associated with the formation of V-shaped valleys. You're going to talk about landforms later. And then we have lateral erosion, which actually can also call bank erosion at the banks. Remember we talked about the sideways. At the side, each side of the river, we call it a river bank. Okay, so at the bank of that river, we have that lateral erosion. So this involves the sideways erosion of the river banks, leading the widening of the river channel. So it kind of widen. Remember, the vertical deepens, but the lateral widens that river. Okay, so it contributes to the formation of floodplains. So we discuss that later and talk about landforms that are formed in rivers. Okay, now let's look at the types of erosion. Okay, we talk about we normally have four types of erosion. So these are the not even actually in rivers alone, but generally we have four types of erosion. Okay, let's talk about the first one, which is hydraulic action. Okay, so hydraulic action is actually, when you hear something is kind of hydraulic, we talk about the force of that water kind of hitting the rocks, maybe the cracks along that river bank, and then the rocks, that force kind of breaks down those cracks and rocks. As easy as that. Hydraulic is kind of like force. Nothing involved, nothing like chemical involved, nothing like temperature involved. It's just force. Then the second, we have abrasion. Now, when you talk about abrasion, think of the materials carried by the river, and maybe they are rough. They are kind of rubbing either the sideways of the river or even the bed of that river. Remember that when we talk about the bed, is that down part, downer part of that river. So the materials that are carried by the river kind of rubbing against the banks or even rubbing against the flow of that river. Understood? So is that action of sandpaper, that material kind of rubbing, the action of sandpaper. Okay, so that's why you say the material being carried by a river is rubbed against the sides and flow of the river, of the channel. This sandpaper action widens and deepens the channels like that. And then we have the third one, which is corrosion. Sometimes you can say solution. Okay, now here is whereby you find the material kind of dissolve. Okay, so minerals in the rocks forming the sides of the river channel are dissolved by the water flowing past them. So the minerals, they are kind of dissolved in that water. Okay, that is a type of erosion. We call it solution. Okay, so these three types act in river environment. Okay, we talk about river environment, but now I've told you that types of erosion, you normally have four. The fourth one is what we call attrition. Okay, so is another type of river erosion, is another type of river process. Of course, it's happening in the river, but does not actually result into landforms, let me say so. Okay, it's just eroding. Okay, so it involves particles of material being carried by a river and becoming rounder and smaller as they collide with each other. Think of materials that are carried by the river and then hitting against each other, then kind of becoming smaller with time. Okay, so this process does not cause erosion of river channel and valleys. That's why I've not included it among the three, because the three kind of erode the river channels and valleys. Then attrition is also a type of erosion actually. So when you think of erosion, think of these four processes: hydraulic action, abrasion, and corrosion. And please know them. Hydraulic action, force of that water. Abrasion, the sandpaper action of that material that are carried by the river. Corrosion, the mixing or the dissolving of those minerals of the rock or even the soil in that water. Then attrition, the material carried by the river hitting against each other to become to kind of round and in smaller pieces, such like. It's clear? All right. Now, another one, we talk about weathering and mass movement. Now, weathering, let's start with weathering. Remember, I talk about breakdown of rock without movement, okay? So, it's a breakdown of rocks into smaller particles. Actually, without movement, that's the key thing here. I didn't write it here, but it's the key thing here. There's no movement there. But movement, talk about mass movement, especially when it's under the influence of gravity. So, weathering, breakdown of rocks into smaller particles without movement. Okay, so we have types of weathering. All right, we have physical weathering. Now physical, just physical. Okay, now this breaks rocks down into smaller pieces. How? It's done by changes in temperature and rainfall, freezing and thawing in rocks and rock cracks. Okay, so think of maybe as rainfall has fallen maybe on rocks, and then because of lower temperature is going maybe to cool. When it cools, it's kind of expands. Remember, it's from kind of a solid, it's ice. Okay, so it freezes, and then when temperatures is high, it expands. You see now it's kind of expanding the cracks of those rocks. That is physical weathering. Is going to break down that rock due to that freezing and then thawing. When I so talk about thawing, is like expansion, and then freezing. Not really thawing is kind of changing into temperature is kind of changing it into high kind of melting. Okay, melting and then freezing, melting, freezing, like that. That's physical weathering. Okay, then we have chemical weathering. This actually involves chemical activity. All right, so this causes rocks to decay and disintegrate. How? It's largely done by slightly acidic rain seeping into porous rocks. Remember, we talk about porous rocks are the rocks that allow water to pass through. So when you have something like an acidic rain, it's going to kind of seep into those rocks, and you know that acid is going kind of to disintegrate that rock. Okay, and or even the rock will decay, and then finally will disintegrate. That is chemical weathering. The third one, we have biological weathering. So when you talk about the biological weathering, is about biology of plants and animals. Okay, so biological weathering, you can have a plant maybe growing into cracks in the rocks. Okay, so it's kind of splitting that rock apart. That's all about biological weathering. You find that maybe a plant has grown on a piece of rock, maybe it's kind of disintegrating that, kind of breaking apart that rock, the root system. Understood? As easy as that. Then we go to mass movement. So in mass movement, we talk about the movement of weathered material downslope due to gravity. Remember, weathering without movement, but through mass movement of weathered materials downslope due to gravity. Okay, so in river valleys, remember we're talking about river environments. Okay, so in river valleys, there are two main types of mass movements. You normally have the first one as the slumping. Okay, slumping is the first one. Now, in slumping, this all normally occurs when, let me just explain it in my own words, whereby you find that this rock or the soil has accumulated a lot of water. It's so wet to an extent that it can't hold any more water. We call it saturated soil. Okay, so you find that due to that being so wet, it's kind of slides down. Okay, it's kind of a sliding due to that heaviness of that soil, due to that high amount of water that is being carried by that soil. Okay, so that's to say, also known as rotational landslides, occur when a mass of soil, rock, or debris move as a coherent unit along a curved or concave surface. So this movement typically happens when the underlying material becomes saturated with water and loses its cohesion, causing it to slide downhill. When you talk about that slumping, something like that. So you see maybe the part of the soil has is so wet to an extent that it can't remain together anymore, so it kind of slump downwards. Okay, so such like thing. So when you see such like thing, that's slumping. That's under mass movement. Okay, then we talk about soil creep. Now in soil creep, it takes time. Okay, so soil creep is a slow gradual movement of soil down a slope over a long period of time, sometimes due to maybe gravity or maybe changes in temperature, freezing and thawing, such like. Okay, not really freezing and thawing, but those changes in temperature that expansion, contraction, such like. Okay, so soil creep is a slow gradual movement of soil down a slope over a long period of time. Okay, so it typically occurs due to the expansion and contraction of soil particles in response to freeze thaw cycles and the force of gravity. You see, so clear like that. So when we talk about soil creep, we have such. Sometimes you might see some trees are bending in such a way. You see that, or even the power lines are kind of bending in such a way. So it's kind of a slow but gradual movement of soil down a slope over a long period of time, maybe due to gravity or the action of like temperature, where you have freezing and thawing of such. So kind of causing such movement of that rock or even soil particles kind of move in such a way. So you find that tree is kind of bending because it's supposed to be here, but now due to the movement of that soil slowly, it's kind of bent, but now the tree has to find its straight growth. Okay, due to the action of sun. Actually, they need to follow the sun for their own making of food, so they'll always turn and grow straight. So you find that they're kind of bending in such a way. Okay, see that. All right, so more is in biology when you talk about that shape of why is it not just bending straight. Okay, more into biology. All right, so that's soil creep for you. Under mass movement. So we've talked about two. We've talked about soil creep and not slumping. Doesn't talk about mass movement. All right. So we talk about now river transportation. Remember we talked about erosion. We've talked about weathering and mass movement. Now we are talking about river transportation. Now, the movement of materials is known as actually as a load by the river. That's river transportation. They are moving. Okay. By the river. Okay, so we have four different ways in which river transport their loads. Okay, so the first one is traction. Okay, traction, that's the first one. Remember, and transportation is written wrongly. Okay, so sorry for this, I'm human, so I can make errors. Okay, so it's supposed to be river transportation, not transportation. Okay, make those changes. Okay, so this is a movement of material known as the load by the river. We have four different ways in which river transport their loads. So you have the first one, traction. Okay, now traction, what is it? Traction involves the rolling of dragging of large heavy particles along the riverbed, not bubbling but just dragging along there. So they are heavy. Okay, that's I want to get this difference. They are heavy materials are kind of rolling or dragging along that riverbed. Okay, the second one, salutation. Now salutation is the hopping or bouncing movement of medium-sized particles over the riverbed. So kind of bouncing. Okay, bouncing, hopping. So that means that they are not that heavy. The heavy ones are dragged and rolled just along the riverbed, but this one, they are bouncing and hopping, meaning they are of medium sized. They are medium sized. Okay, so that hopping and bouncing, that is what we call salutation. Okay, then the third one, suspension. They are being suspended, meaning they are light. Okay, suspension involves the transport of fine particles such as silt and clay. Remember, they are light. Okay, so they are normally transported while they are suspended. So that is that action of suspension. Those materials, salutation, they're still hopping just along the riverbed, but suspension, that's salutation. Suspension, they're suspended. Okay, in the water. And then we have the last one, which is solution. So solution refers to the dissolved load of minerals and ions carried by the river. So remember these now, the minerals are kind of dissolved as they are carried by the river. So you can't see them. They are dissolved in that river. So these are the four process of river transportation. When you're asked in an exam, please don't fail. Traction, the heavy materials being dragged and rolled along the riverbed. Salutation, the bouncing and hopping of the medium-sized particles of the riverbed. Suspension, they are being suspended because they are light. Okay, the fine particles, that's say silt and clay in the water column. Then solution, mixing of those river like minerals and ions, they are mixed. Okay, so they are dissolved actually. Okay, now this diagram will make you maybe understand. You see, so these one are large materials, so they are being rolled or dragged along the riverbed, so we call this action traction. Okay, see that, this traction. And then we have this one of medium size, they are kind of hopping along that river, we call that salutation. Understood. And then we have suspension. You see those light material fine particles are kind of suspended within the river as they are being transported. We call it suspension, okay, being suspended. And then we have solution. You can't see it because the minerals are kind of dissolved, okay, as they are being transported by the river. I think now this is clear. All right, now let's look at the downstream changes in river character. Remember, this is the objective number 2. You should understand how are these kind of changes occurring from the upstream of a river to downstream. Okay, we're going to look at this diagram here to guide us. Okay, so this is the upstream and this is the downstream. Upstream is actually like where the river starts. Okay, so the upstream and then the downstream. So in the upstream, looking at the river discharge. So at the beginning of a river, it's kind of remember we talked about river discharge in part 2. Yeah, part 2 where we talk about drainage basins. River discharge is the amount of water at a given place at that very given time. Okay, so the discharge of the river upstream is less as compared to downstream. So as you move downstream, the river discharge increases. Reason we are going to discuss more. I'm going to explain this more. And then the channel width. Okay, the channel width, uh, you see, as you move downstream from the upstream, the width kind of increases. Okay, so it's kind of going to be wide as you move downstream. Okay, that's the river channel, the width of that river channel. All right, then we talk about the depth. How deep is it? In the upstream is kind of shallow, but as you go downstream it's deeper. Okay, we're going to discuss more on that. Then the average velocity. Now this one, I'm sorry for this diagram, it's on the book, but it's kind of inverse. Okay, because at the upstream is the average velocity of the river is high, and then downstream is low. Okay, so take note of this please, but I've explained it in the explanation in the next slide. And then the load quantity in the upstream is less. But as you move downwards, downstream, the quantity of that load is high. But talk about load size. Here is the quantity, the amount of the materials carried by the river. But what about the size of those materials that are carried by the river? So in the upstream, the size is large. But remember, as you go downstream, it's being eroded. Okay, remember the action of attrition knocking against each other to reduce in size. So the load size is kind of reducing as you go downstream. Then talk about the channel bed roughness. Okay, so in the upstream it's kind of rough. All right, the bed the channel bed is not that smooth. But when you go to downstream, remember erosion also. Okay, it's kind of making the bed to be smooth. So upstream is kind of rough, but you go to downstream, is kind of becoming soft. Okay, then the gradient, it's large upstream, but as you go downward or downstream, the gradient reduces. Now let's look at the explanation of all that we talked about. Now the discharge. Maybe you're talking about how is the discharge of a river changing in the course of a river. You need to explain this. So in the discharge increases the more tributaries join. Okay, remember we talk about the discharge increases downstream. Okay, so why? Because more tributaries are joining in, so they are contributing to a large volume of water. That's what you say. Remember, as the river is flowing, there are some other rivers, tributaries joining, so the discharge is going to be high. That's why you say more tributaries join, so they contribute to the large volume of water. Then occupied channel width, remember, more water has been added. Okay, so there's an increased discharge, so the channel is going to be kind of wide. Okay, so widening channel width due to the confluence of tributaries and increased discharge. I think it's clear there now. All right, and then we talk about the channel depth. Okay, how deep? So remember we talked about upstream is kind of shallow, but when you go downstream, it's deepening. Okay, so deeper channel depth downstream due to the accumulation of water from tributaries. Remember, discharge increases Due to this increased discharge, the width also will increase, and also the depth of that river is going to increase. It's easy, guys, not that hard. It's easy as that. Okay, discharge is going to cause all these because of increasing in the tributaries, such like things. So the depth is also going to increase due to that increased amount of maybe water that is coming from the tributaries. Okay, then we talk about the average velocity here. By I told you in the previous diagram that is kind of the inverse. So velocity decreases. Okay, the average velocity will going to decrease as the river widens and slope leaves the lessons as you move downstream. So when you go downstream, the velocity of that river will kind of reduce. Okay, it won't be that as high speed. Okay, but the upstream is kind of high, and then we can actually have deposition happening as you move downstream, such like. Understood? Then now we talk about the load quantity. So increased load quantity due to accumulation of sediments from upstream and additional input from tributaries. The quantity of load. Okay, there's the difference. We have the quantity and the size of the load. Okay, I get the difference because the next one is the load particle size. So the quantity, it will kind of be increasing as you move downstream due to additional input from tributaries. Okay, but the load size particle, it will decrease downstream as the river slows down, allowing smaller particles to settle. Okay, so the size of that particle is going to kind of decrease. Okay, as you move downstream or the river slows down. Remember, the average velocity is also kind of decreasing as you move downstream, so allowing smaller particles to settle. Okay, it's clear. Then channel bed roughness, I've talked about this in the latter diagram. Lower roughness as the river widens. Okay, so as the river is kind of at the beginning stage, that's upstream, it's rough, but as it widens, it's kind of going to be soft. Remember, also erosion is taking place and then smoothening that riverbed. Okay, so and the bed may consist of finer sediments. All right, then the angle or the gradient, gradual decrease in slope angle as the river flows into flatter terrain. Remember, moving from the upstream is kind of the gradient is kind of high. Okay, when you move downstream, the terrain is going to kind of be flat. Remember, it's widening, reducing, the velocity has reduced, so it's kind of the gradient is kind of low as compared to the top or the upstream side. It's clear? So that is it, as easy as that, guys. Now let's look at the factors that influence the rate of erosion, transportation and deposition in rivers. Okay, so I'm going to look at each one of them. I talk about one factor and then I discuss how it is influencing erosion, transportation and also deposition. Okay, so when you're asked in an exam, how is the name maybe three factors that affect erosion in rivers, so you're going to get, it's actually the same thing. Okay, so the first one, you have water flow and velocity. Okay, water flow and velocity is one of the factors that influence the rate of erosion, transportation, and deposition. How? So erosion, when you talk about water flow and velocity influencing erosion, faster moving water has more energy to erode and transport sediment. Okay, when you have water that is moving faster, okay, so it has that more energy to erode and transport that sediment. Okay, we talk about transportation. Higher velocity allows the river to carry larger and heavier particles. Okay, so when you have water that is flowing very fast, it will kind of be able to the river will kind of be able to carry those larger and heavier particles. Then you talk about deposition. Slower water velocity leads to the settling of sediment, causing deposition. So in an exam, when you asked how is how one of the factors that kind of causes deposition in a river, we talk about slow water velocity. I think it's clear, guys. I think you understand this very well. Okay, so deposition happens when water moves slow. Okay, when the velocity of that water has reduced. Remember, when we talk about higher velocity, even the larger particles or the larger load will be carried by that river. Okay, but now when that velocity reduces, it's going to cause deposition. Remember, you can also be asked in an exam, how is deposition taking place in a river? Talk about when the velocity of that river reduces, the materials are going to settle down, and then deposition will take place. The second one, sediment size and load. All right, sediment size and load. Now, in erosion, how is it influencing erosion? So the river can erode different sizes of sediment, but larger particle may require stronger current. So if we have a large sediment size and load, is going kind of to be difficult to be eroded as compared to those that are small. Okay, so the larger sediment will require stronger currents for them to be eroded. We talk about transportation. Smaller particles can be carried in suspension. Okay, remember we talk about the process of transportation, suspension, traction, saltation, and also solution. So suspension, smaller particles can be carried in suspension, while larger ones may be transported along the riverbed, what we call traction. Okay, such like. And then deposition, larger heavier particles settle fast when the water slows down. Remember, we talk about one of the major things that causes deposition is the slow water velocity. Okay, so larger heavier particles also, when the kind of the sediment size is kind of heavier, is going to be deposited also. Now we talk about the third one, which is the gradient or slope of the river. So gradient, remember you talk about the slope. How is the slope? Is it steep or steep, or each other, the opposite of steep, or gentle? Okay, so erosion, steeper slopes generally increase the force of flowing water, enhancing erosion. Okay, so when we have slopes that are kind of steeper, they're generally going to increase the force of flowing water, and that is kind of enhance erosion. All right, and then we have transportation. Okay, so transportation, how gradient will affect transportation. Steeper gradient can lead to faster water flow. You see, now water will be moving faster, all right, when the gradient is kind of steep, right? So it will be facilitating and transporting sediment downstream. All right, such like. The deposition, gentle slope reduce water velocity, allowing sediment to settle. Remember, one of also the cause of deposition in a river, when you talk about gentle slope, when the slope reduces, water velocity will reduce, and then the sediment will settle. All right, as clear as that. Then we have the fourth one, vegetation and root system. How is it going to affect erosion? So plants stabilize soil. Okay, so reducing erosion. Actually, when we have vegetation, erosion is not going to take place that much. Why? Because those plants kind of will stabilize that soil. Erosion will be kind of hard to take place. So lack of vegetation can lead to increased erosion. That's how vegetation root system influence erosion. How does it influence transportation? Root systems can bind soil, okay, influencing the movement of sediment. Okay, so root system can bind that soil, so they'll influence the movement of sediment. And then we talk about deposition. Plant roots also help anchor the sediment. Okay, remember, a river has met a vegetation, maybe root system. It's going to anchor those sediments, so it reduces the likelihood of deposition in certain areas. Okay, so such like things. So a river is flowing, it has met some root system is going to kind of anchor those sediments, and they are kind of going to be deposited. Okay, that is it. And then we talk about geology and rock type. How is the rock type or the geology going to kind of influence erosion? So geology is like the type of that rock, actually. Okay, geology, the structure, that rock generally. How is it looking like? How is it behaving? Is it soft or hard? Such like. So softer rocks are more easily eroded than harder ones. Geology. Okay, so the ones that are hard are easily eroded than harder ones. And then we talk about transportation. The type of rock affects the size and amount of sediment available for transportation, because if it's hard, then it won't be, you won't get those sediments that can be transported. And when also it's heavier, it's going to make it hard for it to be transported. Okay, then deposition, harder rocks may result in coarser sediments. All right, Remember, when the rocks are kind of hard, it's going to produce that a sediment that is kind of coarse, okay, influencing deposition patterns. Then climate and precipitation, erosion. How is it affecting erosion? Climate and heavy rainfall and intense storms increase surface runoff, enhancing erosion. Okay, so when you have a large or a high amount of precipitation, it's going to cause heavy rainfall that is going to increase surface runoff, which will enhance erosion. And then transportation, it increased precipitation can lead to higher river discharge and sediment transportation. Remember now the surface runoff has been increased and erosion kind of, so it's going to kind of increase cause higher river discharge, and the sediment will be kind of transported more. All right, and then deposition changes in precipitation patterns may influence where sediments settle. Okay, when we have maybe some changes occurring in precipitation, sometimes it's raining, sometimes not raining, so it's going to cause that sediment to be it's going to influence where those sediments will settle. Sometimes when it's so high, precipitation is so high, those sediments, the water will kind of be flowing faster, so the sediment will be deposited at a far, maybe a different place as compared to when maybe it's slow. Such like that's what I mean by it influence where sediment settles. Okay, now I think we are done with this topic. Now let's revise the commonly asked question. We start with the first one. Identify the statement below that describe the channel in the lower course of a river. Okay, now from what we've just revised and talked about, what do you think? What's the answer here? Okay, look at number A, smaller and faster river channel. We're talking about the lower course of the river. Okay, the lower course of the river actually is the upstream. What do you think happens there? Small and fast river channel. Is it true? Okay, wide and deep river channel. Is it true? Okay, narrow and faster river channel. Is it true? All right, small and narrow river channel. Is it true? Okay, that's the answer. So B is the correct one. We are going to have the wide and deep river channel. Why? Because lower course of the river is not upstream but downstream. Okay, downstream. Okay, not upstream, because upper is upstream, lower is downstream. So when you move downstream, the width of that river is kind of widening. Okay, and also the depth of that river is kind of deepening. So when you talk about small, that's very wrong. And small river channel and fast river channel, the first one is okay, but now small no, this one is actually for upstream. Okay, when you have a small river channel, okay, and fast river channel is for upstream. Wide and deep, downstream, which is the lower course of the river. So that's the answer. Then narrow and fast river channel, remember we talk about narrow, it's the upstream. Okay, remember as you move high downwards, it's kind of widening. Okay, and fast river channel, the type of fast, that is the upstream. Then small and narrow, that is actually upstream. It's clear? All right, so A, C, and D all describe the river channel at different parts of its course. Okay, now identify one process of river erosion. What type of river erosion can you see there? You have levees. Is it a process of river erosion? You have abrasion. Is it a type of river erosion? You have overland flow. Is it a type of river erosion? You have discharge. What is the answer? Of course, the answer is abrasion. You remember the sandpaper action, whereby the river uses its material, the load, to rub against the sides or even the bed of that river. Okay, levees, there's a landform. We will talk about it in part 5, so make sure you subscribe. Overland flow, that is when you talk about drainage basins. Okay, not really drainage basin, but hydrological cycle. We have the overland flow or the surface runoff. Discharge, when we talk about drainage basin, this is the amount of water carried by river at that one given time. So the right answer here is abrasion. So A is not correct, is a depositional landform. C is not correct, is a process of transportation. And then D is not correct, as it is to do with the amount of water passed at a given point, given time. Right? Then we talk about these are the questions. State one, process of river transportation. I've given the answer already. So what are these process of river transportation that you know? Name them. If you got them right, bravo. Here we are. Okay. Solidation, suspension, traction, solution. So anyone that you can state, it's okay. All right. You get your mark right. And then state one physical factor that influences deposition in a river. Okay, one physical factor that influences deposition in a river. There's one that you must know because that's the exact thing that we finished with when we have finished the discussion of this topic. The key one. What do you think? Okay, voila. We have the first one, the major one, when the kind of river velocity is reducing. Okay, the sediment size when it's so heavy. All right. Let me talk about the key. When the river velocity is kind of reducing, remember, okay, when the river velocity is reducing, it's going to kind of not be able to carry those sediments along, so it will cause deposition. The sediment size, if it's so heavy, is going to be difficult because it can be transported by that river. The gradient, okay, where the gradient is kind of gentle, okay, so the velocity of the river will reduce and that will result into deposition. Confluences, okay, these are whereby we have those where the tributaries meet that river, we call it a confluence, okay, is going to cause that deposition. Then idea of blockage of barrier or natural, for example, we've talked about trees, vegetation, root system along, it's going to kind of provide that anchorage of sediments so they can be deposited, okay. When a river meets a barrier, it's going to hold those sediments along that barrier, which will cause deposition. Then climatic factor, period of low rainfall. When rainfall is low, of course the distance is going to be low, and then it won't have enough energy to transport those sediments, so it will result into deposition. So all these things, I hope you can know that these are the physical factors that can influence deposition in a river. So all these you should be knowing them on how to explain them, right? Remember, another time you can be asked to explain how sediment size influences deposition in a river, or maybe you're told to name and explain. All right, so make sure you know them and how you can explain both of them. They're so easy like that. And then we move to explain how abrasion erodes the river channel. Talked about this several. It's so easy, guys. When you see abrasion, remember we have four types of erosion: abrasion, hydraulic action, we have corrosion or solution, and then we have attrition. But now attrition has no effect on river banks, river channel, okay? But it can actually cause more erosion as the particles hit against each other. But the rest, hydraulic action and all those, you can actually explain. So abrasion is where the sandpaper action of that river, okay? So you award 1 mark for the identification correct. Remember, you are told to explain, and please always take into consideration this explanation. Make sure you explain, don't just state. Stating, you can just state it, okay, give a statement, and then explanation, you have to explain it fully. So abrasion, what is it? All right. So materials carried by river rubs the side or flow of a river, you get a mark. And then creating a wider, deeper channel, you get another mark because you've explained fully. All right. But when you say just material by the river rubs the side of a flow of the river and then you're done, you won't have explained it fully. So you should at least say it's now kind of widening or even deepening the river channel. You get the second mark. Or even you can say sandpaper action. That is the action of rubbing the side of the flow, and then it widens and deepens the channel. You get a second mark. So you explained how abrasion erodes the river channel. Then we have the also undercutting of river cliff by rocks rubbing against the bank. Such like you get a mark. Then state one physical factor that influences the rates of erosion in a river. Physical factor that influence rates of erosion in a river. All that we've mentioned, guys, you know them. Voila, sediment size, river velocity. I've told you that is the same thing. Rainfall level, that's the amount of precipitation actually. Level of river discharge, the same. But when you're told to explain, please explain. Because when you talk about, for example, sediment size, if it's so heavy, it will be so hard to be eroded. All right. Okay, if the size of the sediment is too heavy. And then river velocity, you see now when the velocity of the river is too high, erosion rates will be higher. Okay, the gradient, when it's kind of a high gradient, steep slopes, kind of going to cause more erosion. Why? Because the water will be flowing faster. Type of bedrock, if it's hard or soft, the hard one will be so hard to erode as compared to the soft one. Okay, the soft one will be eroded faster as compared to the hard one. Rainfall level, when you have high amount of rainfall, is going to cause a high rainfall, a high amount of river discharge, that is going to cause more erosion. Okay, levels of river discharge, the same thing actually. So you see, all these things are just the same, because they can also influence also deposition. Right, don't forget that. It's only that I need you to understand them and you be able to explain each and every one. All right? Factors that influence rates of erosion, factors that influence rates of deposition, factors that influence rates of transportation. The same things, but now different explanations. So make sure you understand them fully from what we've just discussed. Now, explain how the process of hydraulic action erodes the river channel. Guys, you know this. I've told you just the force hits on the rocks, it enters into cracks and then breaks it down. That's all. So you have this. Water hits the riverbed or banks with great force, which dislodges material. Air is trapped in cracks due to the force of the water, such like, and then breaks. You get your 2 marks there. So water hits the riverbed or banks with great force. The first point. Remember, you're told to explain. When you're told to explain in any question, please take into consideration the explanation. Make sure you explain it. Don't just state and leave it there. All right. So water hits the riverbed or bank with great force. 1 point. Then which dislodges the material, which breaks the material, or any word that you can use, but make sure at least you give that full explanation. Then air is trapped in cracks due to the force of the water, such like. Okay. Then we go to explain how a river channel is eroded by solution. Guys, it's easy. Remember, in kind of dissolving, the chemical dissolving, such like, guys. So we have that minerals in the rocks of the river are dissolved as water flows past. Remember to explain, eh? So don't just mention the river are dissolved and then you leave there. Make sure you give some other point that can give you a mark. Okay. So as water flows, the minerals are kind of dissolved. Then soluble particles dissolved in the water, 1 point, due to weak acids in the water, another point. So make sure you give an explanation that will give you more marks. Don't just give an explanation that will just give you a single mark. Understood? That's about explanation. But stating, you can just state that one way and then you are done. The next question we have identify the statement below that describes the channel shape in the upper course of a river. All right. So look at the choices here. We have a narrow river channel. It's in the upper course. Remember, as you go downstream, it's kind of widening. So that is in the upper. It's okay. But shallow sides, no, no, no. That is making it wrong. Then narrow river channel with steep sides. Steep sides in the upper course, very cool, because this is the gradient. Okay, when you have those steep sides, that is in the upper course of the river. Narrow river channel, that is for the upper course. So this one, both of them are right, which is might be it's the answer, not might. Then we have wider river channel. No, that is for downstream or lower course. And then shallow sides, that is when we talk about is in the downstream. And then widest river channel downstream. So it's making everything wrong. So the answer here is B. All right. So B, that's the narrow river channel with steep sides. A is not the correct response. This describes a river in the upper course have steep sides. C is not the correct response, as this describes the river further down its course. Then D is not the correct response, as it describes the river in the lower course. Okay. Then the next question, identify one process of river transportation. Guys, you can tell. River transportation, traction, saltation, suspension, and then solution. So anyone that is one process of river transportation that is here, so we have suspension right there, and that is the answer. Okay, suspension is a process of river transportation. So B is erosion, C that is erosion, deposition, as a process actually. Is correct. Deposition is the process of depositing rather than transporting materials. So these are erosion, then this one is transportation. So make sure you know all those processes, guys. And then I explain one way that river channel shape changes along the course of a river. You see, it's a very common question. The changes of a river along different courses, the upper course and lower course, okay? Upper course, the upstream, lower course, the downstream. So you should be able to explain. So we have to search like, okay? So we award 1 mark for the identification of a feature of the river profile and 2 marks for further explanation of up to a maximum of 3 marks, okay? So candidates could identify downstream river becomes wider. It's very common. We've talked about that severally due to erosion of river channel by bed load. Okay, then wider channel downstream due to greater discharge, creating more lateral erosion. Then meanders are formed due to the erosion or deposition. We'll be talking more of these in the part 5. The meanders, all those. So maybe moving laterally across the lower course of the river. So you identify that one way, and then you explain. You get your 3 points, and then mark this thing, explain. You see, like this, downstream river becomes wider. Why? Due to erosion of river channel by bed load. So make sure you explain with your own words, but now don't leave anything unturned. You're going to get your full marks. All right. Then also the last one, you have the river channel gets deeper in the upper course of the river due to vertical erosion. Okay, such like, get your marks. And now that marks the end of our lesson today. I hope you've learned something, and please, if you love whatever I've taught, you love the way I teach, or you feel like you should add something, maybe you feel I should maybe improve on something, the way I'm delivering these lessons, let me know in the comment section. And guys, I encourage you to watch out part 5 because the video is ready. I'm just to upload it. That is it. Bye bye.